Hi, my name is Ryan Wilkins, and I'm presenting on behalf of Team 8. We did our model on introduction of new technologies to organizational projects and the mitigation of undesirable effects. Um, at a high level, um, what we modeled was an enterprise, and what we ended up picking was a company like Microsoft implementing a new technology like a cloud service for their employees to use to help with productivity gains. And we modeled the adoption that comes along with that new technology. And you'll see more as we go through the PowerPoint. So overall, our agenda is we'll have the introduction and the details of that. We'll have the model description, and we'll go into the details of our model, the results of the model, including verification and validation, our conclusion, and then we'll end with the policy recommendations and the references. Those are more just for background information. I won't really go into detail of those. So for our problem definition, overall, we wanted to be able to model the new technology utilization, meaning that this was really a goal seek curve, and it was measured in percent of the number of the population using this new technology. And so it starts off with, pretty close to 0% and goes all the way up to 100%. This needs to look very similar to the technology adopters curve, where it's really an S curve. Our main variables that we worked with for new technology utilization were the workload and the rework associated with that. Mainly, if there was not first-time quality, then the rework added work back into the workload on top of any new work that was added. As workload increased, you'd also see an increase in the job performance pressure. And what we called this was our external pressures. This was external pressures of people having to work in their daily job, and on top of that, also try to implement this new technology. In addition to that, we also modeled incentives, both in dollars and just in general, people being able to have exposure to management, exposure to new technologies, and um, also with that comes the human level of involvement and attrition. We had a very high priority in this model on the number of leaders that you had adopting this technology. And this doesn't necessarily mean the people in leadership positions, but just in general, the percentage of your work population that has very strong leadership capabilities or leadership characteristics. And overall, our main goal here was to introduce the highest number of leaders possible, and hope that this would help to bring in other people that may be typically laggards and get them to adopt as quickly as possible. And then, of course, one of the main variables, and we studied this throughout the class, was the adoption rate. And this is the way that you move from the potential adopter stock to the technology adopter stock. The goal of any company that's taking a project on like this is to get productivity gains, or maybe it's to gain compliance with a regulatory requirement, or anything like that. So as stated earlier, this problem it's a system dynamics problem. It's been modeled in multiple different ways. It's kind of a traditional problem as we saw in our textbook. And the base of the model, or the base diffusion model that we used, can be adapted in a lot of different ways. In our case, we used it for technology adoption. We followed the process laid out by Sturman to go through the modeling approach. And then what we saw in our behavior was exponential growth, goal seeking, and also some oscillation. And then also you want to make sure there's enough balancing in your model to be able to overcome or reach a steady state when you have oscillation. Like I said before, the reference mode we chose was from Microsoft Corporation, and we found an article where Microsoft is implementing their own product, Azure, the cloud, into their own enterprise for their employees to use. And so this was really an adoption of their own technology that was part of product development, but now is part of their own product development process and any other any other business processes that they might be following. And this was kind of where you can see that there was an S-curve, and I actually put the same results into Excel so that we could use it for a reference mode. And you can kind of see how this goes and follows a typical S-curve. I think that maybe this was a little bit steep in terms of their expectations, but um, as you can see here, they kind of have fiscal year 13 and 14 up until year 2, and then they project out from 15 on to 20. We worked off of 6 main hypotheses, and a lot of these use the main variables I was talking about before, mainly leadership ratio, new technology utilization, workload, adoption rate, workload again, attrition, self-motivation, and then also some product development measures for managing products like the CPI, Cost Performance Index, and the SPI. So this was the overall model that we had come to. In total, I think there are 11 loops, and that shows the influence of leadership characteristics. That is completed through a shadow variable here. We have an organizational inertia loop, a project control loop, executive influence, and so as this technology utilization grows, the contact rate will expose more management to the success of this project. And as you do that, the project controls may actually get tighter. And then what we modeled in the individual goals is that as the project goals get tighter, you may actually have a decrease in ambition, meaning that generally people kind of like to work when there's a lot of freedom. Once there starts to be a lot of rules within this implementation, you may actually see a decrease in people trying to adopt or a decrease in interest of the people that have adopted. Also feeding into the individual goals is the human acceptability to new technology. And that mainly includes the potential technology adopters, but it also includes an interesting variable that we have here, which is called the critical thinking capability. And basically, this is the ability of your employees to be able to think abstractly, take concepts that may not be directly applicable to their job, and help in the technology adoption in order to increase the technology utilization. Another shadow variable we have here that which came from workload is the workforce capability. And this is the ability of your workforce to draw on past experience and their own domain knowledge in order to get work done. And whereas this is a really key variable in achieving work and completing the work that's in the workload stock, it may actually decrease their acceptability to new technology because they'll generally oppose change, um, and they'll want your workforce might just want to do things the way they have always done them. And so that's kind of what it's shown in the individual goals loop. We have a relationship of population on the self-motivation, meaning that as the total population goes up, the number of people in your company go up, it's harder and harder for those employees to kind of stand out in the crowd, and they may actually become discouraged by that. And so that's why we see a decrease in self-motivation here. And then overall, we have an employee retention loop, which actually circles through the total population, through the new people that are potential adopters, and back through to the net flow of people, and then attrition. Net flow of people meaning that if it's positive, then you have people leaving the company, and that would add to the attrition stock. If your net flow is negative, that means you're actually bringing in experienced people to help either with your technology adoption or because your workload requires you to bring more people in. And this can actually be um, directly impacted by job performance pressures. So you may want to actually try to alleviate job performance pressures by bringing more people in, and that's what's shown in the total population here. That kind of completes that loop. The workplace communication and word of mouth. These are the typical loops that you would see in the base diffusion or technology adoption curve. And then also we have a loop for rework, which brings a percentage of the workload back into the workload increase and back into workload. So for our model, we use 10%. 10% of the work that was completed need to be reworked. And this just kind of gets into the details. This is the typical base diffusion model here. You can see that through synthesis we were able to tweak certain variables, and then through that be able to see how the adoption rate was changed by this. Next, we have the organizational inertia loop, which was kind of a key loop for us outside of the typical base diffusion model. And this includes the leadership ratio like I was talking about. We used 20% for that. So 20% of the total population had strong leadership characteristics. And by introducing more leaders into the group, we were hypothesizing that we could overcome the inertia or organizational inertia that you would typically see in this large number of employees. And also feeding into this is the human level of involvement. So trying to get more people involved. And the more people that get involved, the more people that they will get involved. And that's kind of overcoming the organizational inertia here. And feeding into that is the individual ambition. And then, of course, as more people adopt, you'll get other people to take a look at the technology, and hopefully they'll adopt as well. Like I explained before, the more people that come into contact with this project, the more management exposure we'll get. And this is kind of the project visibility to executive level here. And then, of course, as more management gets involved, you'll actually start to see tighter project controls. And this can have positive impacts in incentives and other things that can also have negative impacts in the ambition of individuals. Like I explained before, this is the employee retention loop. And like I said, we have a net flow of people that feeds into the organization workforce demand. That feeds back into the new people. It also feeds into the job performance pressures and back into the net flow of people again. The employee retention loop um, impacts the new technology adoption in a couple of ways. One thing that we noticed is that in the regular model, we actually had total population being a constant, whereas in our model, total population can fluctuate. And with that fluctuation of the total number of employees, you're actually adding new people in as potential technology adopters. So in addition to the regular challenge of just trying to move this fixed number of people over to technology adopters, you're also constantly adding more people in. And as we saw in our results, this does have a pretty big impact on the technology adoption. And it also, when trying to debug our model, it definitely added some complexity to the model itself. This was our workload model, and this was kind of another exogenous, well, it could have been an exogenous variable, but it was actually a whole model in itself that would actually feed into job performance pressures, and the job performance pressures fed back into a lot of different points in the model. And so basically what we did with our results was, with our analysis, is we actually looked at what happens when workload is increasing, what happens when workload stays kind of at a steady value, and what happens when workload is decreasing. And we wanted to see how that impacted the job performance pressure, and then through that, how that would impact things like technology utilization, um, adoption by people who with strong leadership skills, and also how that might also impact the attrition within the company. So to verify our model, the first thing we did is we looked at our reference mode. The blue line is actually the Azure cloud adoption that I was referring to earlier. Within our model, we had a variable for new technology utilization, which, like I said before, is just technology adopters divided by the total population. And once we were able to produce results, we used this reference mode and we plotted that against our own baseline graph. As you can see here, the red line, which is the reference mode, is a little bit of a steeper curve than our baseline, but they both still represent S curves. And I think from a modeling perspective, I think our curve represents more of a standard curve, whereas this might actually be a little bit more of a realistic set of values that we would compare to. And then also the next thing we did was what you can see in the blue line, which we changed the initial population variable to 1,000. So you can see that in 3 different order of magnitudes with the initial population, our results stay the same. So for our first hypothesis, which was leadership ratio impacts new technology, this was kind of something that we would have liked to seen better results in our model. And if we were to have a 2.0 of this model, we actually would see better results. But one thing that we noticed here is that as our leadership ratio increased, as you can see from 10%, baseline is 20% to 30, all the way up to 100, we don't really see a huge change in the technology utilization. And this is something, like I said before, we were really expecting to see a lot bigger difference. But I think a couple of tweaks in our model probably could have helped us with that. But as we sit here, it's not making a huge difference on our technology utilization results. Next is hypothesis number 2 and 3, which is that a change in the workload would impact the new technology utilization. You can see here that we have an increasing workload, which is our baseline. We have a pretty steady workload level here, and then we have a decreasing workload. What you can see is um, that this actually also doesn't really have a huge impact on the technology utilization, but it does have a pretty big impact on job performance pressures and also in attrition. Um, and then attrition actually ends up having a pretty decent impact on the adoption rate and then on the new technology utilization. So another focus on the leadership ratio here was that it significantly impacted project controls, attrition, self-motivation, and also that it would have a higher adoption rate. Like I said before, we were kind of disappointed with the results we saw from increasing leadership ratio, but I think we're a couple of tweaks away in our model from really being able to use this as a key indicator of the projects. The last one was with the product development project measures of CPI and SPI. You could see that different CPI and SPI values would actually change the performance pressures, it would change the workload, and also the rate at which we increase and decrease the workload. And these all have pretty big impacts on the technology utilization and adoption. So in our conclusion, you can see that the human level of involvement, the human acceptability, and the job performance pressures, those are all major components in our model. Also, contact rate and the individual ambition had huge impacts on the adoption rate. Um, and like I said before, a couple of tweaks in our model would have led to leadership ratio impacting contact rate quite a bit. And we think that this would have been a key indicator in the success of the technology adoption. And then also, as you can see, the organizational inertial loop and the executive influence loop both had huge impacts on the leadership stock. And then also workload and job performance pressures were big both in the motivation of employees and the attrition, which impacted total population, and also fed back into the adoption of the people with leadership characteristics and also the overall technology adoption. These are our overall policy recommendations, which I'm not going to go through now, but this was, like I said, just kind of a reference point. And then here were all the references that we were able to use. Thank you for your time.